Hey everybody, so in our previous video posted to the YouTube channel, I added a math tutorial video on long division strategies. As you know, in 5th grade, the students are extending their knowledge about long division and their strategies by one, building on strategies they've already began to learn, and two, they are now going to be dividing whole numbers that are larger. So multi-digit numbers and their divisors are getting much larger as well. And of course, they'll also be dividing decimals. But for now, those strategies in that previous video, when we're dividing whole numbers by 2-digit divisors, I showed you how the kids have learned how to estimate the quotients before beginning the problem, whether that be a problem with just the numbers or whether it be a word problem. We also learn how to use the tape diagram model so that we can show our thinking in a pictorial representation. And then also we moved to an abstract method by using the vertical method, and that was also demonstrated within one problem. This highly connects to the standard division algorithm that we'll be getting into. And then at the end, we learn how to check our answer with the multiplication equation. Today I'm going to show you how to use the area model as well as the partial quotients model, which are two strategies that the kids should have learned previously. But I'm going to use those to show us how to divide multi-digit numbers, whole numbers, by 2-digit divisors. And so you'll see that strategy and how we use it in class and how the kids are expected to use it, as well as we're kind of continuing on with what we know. So we continuously talk about the parts of this problem and what it means, and not just being able to read that as an expression of 632 divided by 26. These are things that sometimes the kids mix up with writing it, and especially applying that in a word problem, knowing which number it is that's getting divided. So we use the terms dividend, we use divisor, we talk about what's being split up. So we're putting all of that into context. This is not a word problem, so we're just going to go with the strategy. With the area model, you're going to set it up in this way. We're going to be putting inside here, and I'll make connections to vertical method and all the other stuff too. And so they know that when we do that, I like to leave mine open in case I have to extend it, that the number, the dividend that's getting split up is going to go on the inside. All right, we'll start there. And then the divisor, that goes on the outside of this, and that either is going to tell us our group size or how many groups. And so here, this is going to be our group size. Then we're figuring out up here what all the smaller quotients are going to be, and that goes up top. Since we're starting with the number 632 that is being divided in the smaller parts at a time, that's going to go on the inside because this is where the total dividend is going to go. And so for this strategy, what I've taught the kids is they can think about it this way. 26 times what number will give us something that is close to 632, so they can approximate, or equal to that amount if there's, a number that they can be equal to. And so everything we've been learning, we've been building on about multiplication, multiplying by multiples of 10, multiplying by multiple powers of 10. Using that mental math for that comes in handy so that they can approximate a little bit more closely. And so they know to go and work out their problem so that they can do that here and see. This number is in the hundreds, right? And so when I'm thinking about what the multiples that I'm going to do for 26, I'm not going to go stay in the ones, right? And so what will get me close to that? Well, if I do it in the tens or powers of 10, then 26 times 10 is going to give me 260. If I do 26 times 100, if I go in hundreds, that is going to get me a lot higher. So that's going to be 2,600, which that product is a lot larger than that. So I can't use 100. I got to go smaller than that. So it's probably going to be multiples of 10 that I have to use. It can be any number as long as it is not higher than this dividend right here. Okay, so I'm going to test out numbers. This is my space to test out those numbers here. So I'm going to do 26 times, let's do 30. All right, so I know that I got to do vertical. Look at it vertically. That would be 18, and that's 780. Okay, that's over that, so I got to go less than 30. So I'm going to try 20. That's 12, and that's 5. Okay, so that's less than that. That works. So I'd like to touch the numbers. 26 times what number gave me something close to that? So I'm going to plug in 26 times 20. That number, that quotient, is partial. That means we haven't satisfied the entire dividend. So it's a partial quotient that goes up here as well. Even though this strategy is called partial quotients, in area model you're collecting partial quotients as well. So 26 times 20, all right, 20 times 26 gave us a product of 520. That gets subtracted from what you started with. And so what we have left is 112. Okay, whatever is left over, if you have a remainder, and that remainder is enough to get more groups of that divisor, then you got to keep dividing. That's what I tell the kids. It's not just a leftover. It means that, okay, we can accommodate more groups. So I'm going to take this amount and send it over here, and this becomes the dividend we have left to divide more. So we're continuing up here to add up the partial quotients that we're collecting along the way. So now going back here, 26 times what number gives me something close to 112, if not equal to it. I'm looking at what I have here. I know I can't use 20 because that's way too much. 26 times 10 is 260. That's too high. So let's split that in half. I'm going to do 26 times 5. Let's see what that comes up with. So 26 times 5 is 130. I'm getting there. I just got to keep going down. And that's 104. That's less than this. So that means I get to use 26 times what number? 4. So we're going to put that there. And 4 times 26 gave us 104, which has to be subtracted from this number right here. And because we need to regroup, okay, 12 minus 4, we have 8 left. This is not enough to get a group of 26, okay? So this becomes our remainder, all right? So the quotients, the partial quotients that are up here, all right, these all stand for our quotients, or partial quotients, rather. We have to add those up. So we got our 20. That's why we put our plus signs in between. We have our 4, and that's 24, all right? And then we also have a remainder left over, and that's 8, okay? So the equation from there, the equation that we write to check it will have to be whatever the quotient is, which I also talked about that in the video. Then you multiply that times your divisor, okay, plus any remainder if you have one, and in this case we do. So we plug that in. Our quotient, once we added it, was 24, and we multiply that times 26, and we do have a divisor, we do have a remainder plus remainder of 8. Okay, and I'm already teaching them how to group this off. So we're going to group those two together because what's coming ahead is going to be order of operations. And so that will be how you do that part. And then, of course, to check it, you would then do 24 times 26. Let's do that math. Alright, so we'll put our 0 here because the 2 is in the tens, and anything times 10 ends in a 0. 2 times 4 is 8. 2 times 2 is 4. That's 4. It's getting real small down here. 12 plus the 1 is 6. 624. So we got 624, but remember, we have a remainder. 6, so we got to do that first. 624 plus 8. That's 12. That's 32. So this is what we ended up starting with. That's what's supposed to happen. So again, everything keeps stacking. These skills keep building on each other and their connections that they're making, okay? Next, I'm going to show you the partial quotient strategy with the same problem. Okay, so we've done some math that's kind of helped us, so I'm going to cheat in this case, but I'm not going to use the same exact numbers, okay? So essentially, the dividend goes inside, so this is going to resemble the vertical method, and it's supposed to, right? But we're going to stack our quotients vertically up top here. And same question gets asked. 26 times what number can we put here? That's going to get us something close to 632, if not equal to it. So as long as it's not higher than that number. Okay, the last time we started off with 20. I'm just going to, just for giggles, I'm going to start off with 10. Placement of the quotient is important because you can't just, I tell the kids, you cannot just place it anywhere. If we were to put the number 10, I might have addressed this in the last video, in this spot here, right? Then what happens is that shifts the value of this number. And that means, because there's nothing here, essentially that this is 100. And so 100 times 26 is 2600. That ain't what we want, all right? We want 260. So, because the value of the 1, or the 1 was over the hundreds place, so its value is based on the place that it's over. So we need to shift and make this 10, all right? And so now we have, let me do that in blue, 10 times 26, and that is going to be 260. We've already gotten that, okay? We're going to subtract that from here, and we'll keep going. So now we have 372 left, okay? We can go with any numbers, right? But again, as long as it's not larger than the dividend you have remaining, and that works, it's going to get stacked there. So 26 times what number will get me something close to 372. All right, so I can use the numbers I have, the ones that work, okay? I see I can do 130. I can even do 10 again if I wanted to, which totally works. I can do 15. So I think I'm going to try 15. So 26 times 15 is essentially here. Because I already did 26 times 10. And that gave me 260. Plus, I did 26 times 5. Okay, this is like partial products, okay? And that gave me 130. Let's see if that works. I don't think so. 390, just a little bit over. So 15 does not work. Okay, so let's do 10 again. 10 times 26 is 260. I'll take that off. That's 212. Okay, so now we can look over here to see what's going to work. All right, 26 we did times 4. All right, so let's put a 4 up here. It could have been any number. It could have been smaller than that. It just means that it'll take you longer to get there, right? And that's totally fine. So 4 times 26 we got 104. So we're going to subtract that. And after we regroup, that becomes an 8. Okay, which is our remainder. And what we do with these products here is we add them up. Because those are our, not products, our quotients. Those are our partial quotients. And once we add them up, you can see we got 24 again. And then we had a remainder right here that we have to put, and that's remainder 8. So our equation to check it, again, remains the same. This should not change, okay? So we have the quotient times the divisor plus anything remaining behind. So we got a total of 24 times 26 plus 8. Okay? Now, obviously, I would ask the kids to check it using this equation. Oh, I'm sorry. I missed the part. Okay? What we're supposed to do is equal to. So the equal sign, it could be on either side. We started with 632. I put that. 632. That's what it should be, because it's an equation. Before, it's just an expression without that. So now we have our equation. And I'm not going to recheck this because we've already checked it for accuracy by multiplying it out, and we added our remainder with it to get 632, so we know that this is correct. So moving forward, obviously this is a strategy that can use with multi-digit numbers, 2-digit divisors, even when we expand to 4-digit dividends or beyond that. These strategies work for that. We will end up landing on a standard algorithm. However, this helps us to see other strategies and how they work. It helps the kids to estimate, approximate, all of that, which is our skills we definitely want to solidify. This is why all of that stuff preceding this benefits them, and making sure they're solid in those skills, so that when it gets to these harder concepts that keep building on each other, they're relying on their previous knowledge about it, okay? Alrighty, I hope this helps.